Right now, you are sitting perfectly still. Maybe you're in bed, maybe you're on the couch. Either way, you're not moving, except you are. As you listen to this sentence, you are traveling at roughly 2 million kilometers per hour. You, right now. And the strangest part isn't the speed, it's that you can't feel any of it, not even a little. Let's count your speeds, from slowest to fastest. Layer 1, the Earth is spinning. If you're standing near the equator, the ground under your feet is moving at about 1,670 kilometers per hour. That's faster than a passenger jet. Your chair is currently outrunning a Boeing 747, and it isn't even trying. Layer 2, while it spins, the Earth is also falling around the sun at about 107,000 kilometers per hour. At that speed, you could fly from New York to Paris in 3.5 minutes. You're doing it right now, in your pajamas. Layer 3, the sun isn't sitting still either. It's dragging the whole solar system around the center of the Milky Way at about 828,000 kilometers per hour. Even at that speed, one lap takes 230 million years. The last time we were on this side of the galaxy, dinosaurs were the new thing. You might be wondering how anyone measured all this. We never left the galaxy to check. The answer is light. When something moves toward you, its light gets squeezed bluer. Moving away, it stretches redder. It's the same reason a passing ambulance drops in pitch as it goes by. Astronomers point their telescopes at distant stars, read the color shift, and from that alone, they can clock exactly how fast we're moving and in which direction. We measured the speed of the whole planet without ever stepping outside. And layer 4, the entire Milky Way is falling through space towards something enormous at about 2.1 million kilometers per hour. Add it all up, and sitting still is the biggest lie your body has ever told you. And here's the part that breaks people. Everything we just counted, the spin, the orbit, the galaxy, the plunge, all of it happens inside space. But space itself is also growing. Every second, the distance between faraway galaxies stretches wider. The most distant ones are racing away from us faster than light, not because they move, but because the space between us keeps being created. So even if you froze every planet and every star, you still would not be standing still. There is no still, not anywhere. So why can't you feel any of this? A man figured it out almost 400 years ago. In 1632, Galileo asked people to imagine a windowless cabin on a smooth sailing ship. Drop a ball, watch fish, swim in a bowl, pour water into a cup. Nothing changes whether the ship is docked or gliding at full speed. Inside that cabin, there is no experiment that can tell you the difference. None. Constant speed is invisible, not hard to notice, impossible. Galileo had stumbled onto one of the deepest rules in all of physics. There is no such thing as absolute rest. Ask yourself right now, am I moving? And the only honest answer is, compared to what? Compared to your chair? No. Compared to the sun, you are screaming through space. Both are equally true at the same time. Motion is not a thing you have. It's only a thing you have relative to something else. Nobody in the universe gets to say they're the one truly standing still. People didn't believe it at first. In the 1830s, when the first passenger trains reached 50 kilometers per hour, respected doctors warned that human bodies might not survive. Passengers wouldn't be able to breathe. Minds would rattle apart. Then the trains ran and everyone was fine. Slightly bored even, because the body doesn't care about speed. It never did. You don't need a time machine to feel how wrong our instincts are. Next time you're on a plane at cruising speed, pour yourself a coffee. The stream falls perfectly straight into the cup, exactly as it would in your kitchen. You are moving faster than a rifle bullet, and the coffee has no idea. Roll a ball down the aisle, and it rolls straight. Toss a peanut up, and it lands back in your hand, not 3 rows behind you. Inside that smooth ride, 900 kilometers per hour simply does not exist. Here's the biology. Your sense of motion lives in your inner ear, in tiny tubes filled with liquid. And that system is not a speedometer. It's an accelerometer. It only fires when your speed changes. That's why you feel an elevator start and stop, but nothing in between. It's why a plane going 900 kilometers per hour feels like a slightly noisy living room. Your body doesn't measure motion, it measures surprises. Want the extreme version? Astronauts on the space station circle the Earth at 28,000 kilometers per hour. They see 16 sunrises a day, and inside, they float around like it's a quiet hotel. Some describe it as the most peaceful place they've ever been. 28,000 kilometers per hour. Peaceful. But wait, if astronauts are moving so fast, why do they float? Here's the twist. It's not because they escaped gravity. Up there, gravity is almost as strong as it is down here. They float because they are falling. The whole station is falling toward Earth constantly, but it's also moving sideways so fast that it keeps missing. It falls and misses and falls and misses forever. That's all an orbit is. Falling with style, and everything inside falls at the same rate. So nothing has any weight. Okay, but if the Earth spins that fast, why aren't you thrown into space? Because gravity is winning massively. The spin does push you outward a little. At the equator, you actually weigh about 0.3% less than at the poles. For the spin to actually launch you, Earth would need to rotate about 17 times faster. Until then, you stay. So the spin cannot throw you off. But here's a darker thought. What if it suddenly stopped? If the Earth froze in place in an instant, you would not. You'd keep moving sideways at 1,670 kilometers per hour, and so would the oceans and the air. Everything not bolted to bedrock would be swept sideways in a single catastrophic gust. The atmosphere alone would scour the surface flat. It sounds insane, but it's the same physics as a car crash. When the car stops, you don't. Speed you cannot feel is still speed that can kill you. For centuries, people said, fine, but prove the Earth moves. In 1851, Léon Foucault hung a 67-meter pendulum from the ceiling of the Pantheon in Paris and let it swing. Hour by hour, the swing slowly rotated, tracing a circle nobody was pushing. Except the pendulum wasn't turning. It was swinging perfectly straight. The floor was turning underneath it. People reportedly went pale. The building was moving. The city was moving. They were moving. That same turning ground bends things in flight. Winds, ocean currents, even long-range artillery all curve because the Earth rotates underneath them. It's called the Coriolis effect. But here's where everyone gets fooled. You've probably heard that toilets and sinks drain the opposite way in the two hemispheres because of it. That one is a myth. The Coriolis effect is far too weak to steer something as small as your sink. What actually decides the swirl is the shape of the basin and how the water went in. So the Earth really does bend hurricanes. It just does not care about your bathroom. Once you know, you see it everywhere. Hurricanes spin because winds get bent by the turning Earth. Snipers correct their aim for it. And tonight, when you watch the sunset, remember, the sun isn't sinking. You are tilting backwards at 1,670 kilometers per hour. The sunset is you leaving. Your motion even tips the sky itself. Picture running through straight falling rain. The faster you run, the more the rain seems to slant toward your face, and you tilt your umbrella forward to meet it. Starlight does the exact same thing. Because you're hurtling sideways through the galaxy, the light of every star arrives very slightly tilted, nudged toward the direction you're heading. Astronomers call it aberration, and it's real enough that telescopes have to correct for it. Even the positions of the stars are quietly rearranged by a speed you will never feel. But hold on, if all motion is relative, what does 2 million kilometers per hour even mean? Compared to what? Here's the beautiful part. The universe left us a reference. All of space is filled with a faint glow left over from the Big Bang, and our motion squishes that glow. It's slightly warmer in the direction we're heading, slightly cooler behind us. It's the closest thing to an absolute speedometer that exists, and it reads 2.1 million kilometers per hour toward a region of space we can barely see, pulled by something astronomers literally named the Great Attractor. And it gets stranger. Because you are moving, time itself bends for you. Just a little. Einstein showed that the faster you move, the slower your clock ticks compared to someone at rest. The effect is tiny at everyday speeds, but it is not zero. Astronauts who spend months racing around the Earth come home a fraction of a second younger than the rest of us. They have literally time traveled into the future by a hair. So your hidden speed does not just move you through space, it quietly shifts you through time as well. So let's stack the whole tower one more time and really let it land. Right now, you are spinning at 1,670, orbiting at 107,000, riding the galaxy at 828,000. diving with it at 2.1 million kilometers per hour. Space beneath all of it is stretching wider every second. Your clock is ticking a hair slow. The starlight is tilting to meet you. All of it at once, while you sit in a chair convinced that nothing is happening. Your body reports one number for all of that motion: 0. It's the most confident wrong answer in the universe. So why would evolution hide the greatest ride in existence from you? Imagine feeling it, all of it. The spin, the orbit, the galactic dive. You would be seasick from the moment you were born. So your brain does what it always does with signals that never change. It deletes them. The hum of the fridge, the clothes on your skin, the fastest journey ever taken. If a signal never changes, your brain decides it isn't information, it's furniture. So try it. Try to be truly, completely still. Sit down, hold your breath, stop every muscle, and you are still spinning, still orbiting, still falling through the galaxy at 2 million kilometers per hour. There is no button, no place, no moment where the motion stops. From your very first breath to your very last, you are in flight. We spend so much of our lives wishing things would just hold still for a second. They never have, not once. And maybe that's the point. You were never meant to sit still. You were meant to move. So tonight, when you lie down and close your eyes, perfectly still, remember what still means. By the time you wake up, you'll have traveled about 70 million kilometers. No ticket, no seatbelt, no feeling at all. It's the greatest ride ever built, and you're on it right now. Honestly, try to enjoy it.